10 incredible optical illusions. 10. Negative photo illusion. Focus on the dot in the centre. After 30 seconds, the colours change to show a natural landscape. The screen has really changed to grayscale, but the illusion causes us to see realistic colours until we blink or look away. Known as a negative photo illusion, it occurs when we overwork cone cell receptors in our eyes. These overwork in conflict with rod cells, which interpret opposing colour. When the cones fail, the rods continue to tell the brain it's seeing opposite colours, so magenta becomes green and vice versa. 9. Blivets. This is a blivet, otherwise known as a devil's fork. Looking at it from the top, we see 2 rectangular rods, but focusing on the bottom, we find 3 cylindrical poles. When our brain is confronted by an impossible object like the blivet, it tries to explain it by interpreting it as a familiar object, in this case a fork. The object made a cameo in The Simpsons Treehouse of Horror 8, when Lisa picked one up at a garage sale. 8. The Ebbinghaus illusion. Like colours, our perception of size can be influenced by surrounding objects. This is proven in a famous illusion known as the Ebbinghaus illusion. You'll notice the 2 central circles appear to be different sizes. However, take the outer circles away and they are actually the same size. Visual clues, in this case the outer circles, lead our brain to misinterpret size. In the context of being surrounded by bigger objects, the objects in question appears smaller and vice versa. 7. Grey dot grid. Grey dots appear between the sections of this grid but disappear if you focus on one intersection. When we focus on something, we actually see shapes and colour, but the part of our eye used for peripheral vision sees in a lower resolution, meaning it only perceives rough shapes and needs to dim brightness. When our eyes become flooded with light from the grid's bright white intersections, they struggle to see accurately, triggering the grey dots. 6. Herring illusion. You might think you are looking at curved red lines overlaying black lines. However, the red lines are actually straight. It takes 1/10 of a second from the moment light hits the retina for the brain to understand what it's seeing. To compensate for this, it tries to predict the future. In this case, our brain tries to guess what would happen if we travelled toward the centre point of the black lines, causing them to look curved. This foresight allows movements such as catching. 5. Troxler's fading. Focus on the cross in the centre and you'll see the lilac circles that surround it fade away, before reappearing as green. This happens when our retinas become oversaturated with lilac, so replace it with its complementary colour, green. In this second version of the illusion, the lilac circles are still, while the disappearing space moves. By focusing on the cross, our visual neurons are prevented from noticing things that are stationary and become more aware of moving objects. 4. Spinning dancer. 2/3 of us will see the dancer spin clockwise, while the rest of us see her move anti-clockwise. However, keep staring at the image and she eventually changes direction. Because the image is completely black, it offers no depth or visual cues, meaning our eyes will interpret it differently at different times. By adding in lines or shading, we prevent the arms and legs from seemingly passing through the body. If you're having trouble seeing the change, try looking at it with your peripheral vision. 3. Spinning wheels. When you look at the screen, you should see a group of rotating rings. Try focusing on just one of the wheels and you'll notice that it seems to stop moving, while the others continue to move. In reality, you are looking at a stationary image. Scientists have suggested that we interpret them as moving due to involuntary eye twitches. Another explanation could be that when our eyes flick around the image, we confuse the motion detectors in our neurons and falsely interpret movement. 2. Confusing colours. In February 2015, the internet was divided over whether a dress was white and gold or black and blue. The dress was black and blue. However, the reflected light which bounced from the background objects in the photo confused the brain's perception of colour. While the brain normally discards reflected light colour in order to perceive an object's actual colour, in this case, the confusing background light made that difficult. Different brains ignored different colours, discarding either blue or gold tones, leading to a huge online debate. 1. Cafe wall illusion. This illusion shows a wall of slanting dark and light tiles. However, in reality, the tiles are perfectly straight. We see the tiles as wonky only when separated by a thin grey line. Remove this and the illusion is shattered. The phenomenon occurs as neurons in our brain react to the contrasting colours of the tiles. Our brain blends tile halves that match colours above and below to create illusionary slanting wedges. The illusion was first noticed in real bricks on a cafe wall.
Ten weird facts about dreams. Number 10. Threat simulation. Dreaming may be an evolutionary technique that helped humanity survive by allowing us to practice responses to threatening situations while we sleep.